So how does the heart contract? The thing that you really need to remember about how the heart contracts is that the heart is myogenic. The meaning of this is that the contractions within the heart muscle, which we call the cardiac muscle, those contractions originate from within. Okay? The initiations of the contractions are within. That's why we say that the heart muscle or the heart itself is actually myogenic. Okay? That means that it does not need to receive impulses from somewhere else for it to contract. Okay? So it has that inbuilt, the word intrinsic, inbuilt ability. Within itself, it has that ability to ensure that you have continuous rhythmic contractions without fatigue. Basically, it doesn't get tired. Okay? If the heart stops, then you will have problems sustaining life. Okay? So that is why, even if it is removed from the body, it continues to beat. So yes, we are saying that the cardiac muscle initiates the contractions, but what part is responsible for that? That part is what we call the sinoatrial node, abbreviated as SAN. So that part is what we are having here. That part is located near the superior vena cava in the right atrium. This is the superior vena cava, and this is the right atrium. That's where you find the point where the heart contractions start from, and we call that point the sinoatrial node. The other name is the pacemaker. We can call it the pacemaker. Okay, so it generates the electrical contractions, so electrical impulses or electrical potential. That's where the electrical impulses start. And then they spread to the atria, both of them. So this here spread in that direction, but also in that direction. Okay, so it spans the atria. That means that even if we have it located in the right atrium, it spreads to both atria. And then again, it will travel across the atria, causing the contractions. And this will actually also lead to the contractions that you have in the ventricles. Okay, when we have the contractions up, the blood is definitely going to be pushed into the ventricles. Okay, and now another point which is very important is the atrioventricular node. That means we are talking about a node between the atria and the ventricle, and that is another very important point. So it is here. So at that point, still electrical impulses are going to be transmitted. But what happens at this point is that there is a slight delay. Okay, there is a slight delay of about 0.1 seconds. So this delay is important because it allows the atria to fully contract such that no more blood is left before going into the ventricle. So it means that it wants the atria. This delay is important in ensuring that the atria actually empty the blood into the ventricles before now the ventricles can be activated to contract. Okay. Now at this point, at this atrioventricular node, the impulses will pass through this septum here, where we will have the band of His here. From the band of His, the electrical potential will spread outwards through these fibers that we call the Purkinje fibers. Okay, so these Purkinje fibers are the ones that will stimulate the ventricles to contract and pump blood through the aorta and the pulmonary artery. So every time you have the valves closing, you have a sound. When the atrioventricular valves close, then you have the lap. So it means the lap is the first sound. Then when the semilunar valves close, then you have the dap. So it is lap first, dap next, because it is the atrioventricular valves that close first, and then the semilunar valves will also close later. So what we have just seen is the route taken by electrical impulses. We are saying that they are generated from the sinoatrial node. From there, they spread to the atria. And then when they reach a point which we call the atrioventricular node, you will have some slowing down. And that will allow the atria to empty into the ventricles, because there are two. And then from that node, from the atrioventricular node, through the band of His, and then finally into the Purkinje fibers outwards. So these are the ones that will cause the heart to contract, the ventricles to contract and push the blood through the aorta and the pulmonary artery. Okay? And then we have the lap and then the dap sounds. The first one is when the atrioventricular valves are closing. The second one is when we have the semilunar valves closing, the dap sound. So that is how the electrical impulses move. That's the path they take. Now,